Hello, hope you all have a good Easter break. Today our group will present about green AI. So let's start from the introduction. Since 2012, gameplay, speech recognition, object recognition, and machine translation had a remarkable leaps, which has been reported by the field of artificial intelligence with a huge range of capabilities. Our presentation goes to introduce red AI and green AI, including definitions, reasons that why they are recommended, advantages and disadvantages. Finally, we will make a conclusion about a comparison between the red AI and the green AI. Then we try to do some analysis of risks, then proposing some solutions. Now let me introduce the red AI. The first question is what is the red AI? Red AI refers to AI research that seeks to improve accuracy through the use of massive computational power while disregarding the cost, essentially buying stronger results. There is the equation of red AI. All means of letters are shown here. And then I will talk about advantage and deficiency. So it is obviously by literature review in recent years, the amount of red AI was used in training deep learning model has increased greatly, which means that red AI is widely used in research. The high accuracy. It can be said that this is advantage or deficiency. Combining with picture one, we can find that more research means higher cost, while red AI, which only focused on accuracy, ignores efficiency and other aspects. The negative impact of low income and high cost was increasing. At the same time, red AI was not friendly to junior researchers, which made it difficult for many researchers to carry out AI research. So the article presented another method, green AI. Then let my partner Jerry continue our presentation.
However, this article presents an alternative is green AI, which is advocate method in article. So what is green AI? The term green AI refers to AI research that yields novel results while taking into account the computational cost, encouraging a reduction in resource spent. Green AI treats efficiency as a primary evaluation criterion alongside accuracy, whereas red AI has resulted in rapidly escalating computational costs. Green AI promotes approach that have favorable performance trade-offs. If measures of efficiency are widely assessed as important evaluation metrics for research alongside accuracy, then researchers will have the option of focusing on the efficiency of their modules with positive impact on both inclusiveness and the environment. So why we will use green AI? Green AI will decrease AI's environmental footprint and increase its inclusivity. In about decades, the introduction of a simple, easy-to-compute efficiency metrics that could help make some AI research greener, more inclusive, and perhaps more cognitively plausible. Compared to red AI might be the case that at certain points price will be too high, forcing even researchers with large budgets to develop more efficient measures. Then Mr. Lee will continue our presentation.
Now allow me to introduce to you the measures of AI research. AI research can be computationally expensive and harmful to the environment in a number of ways, but it provides opportunities for efficient improvements. Here, this article reviews several measures of AI research that could be reported and optimized, and advocates one particular measure, FPO, which should be reported when AI research findings are published. These measures include carbon emission. Carbon emission is appealing as it is a quantity we want to directly minimize. Electricity usage. Electricity usage is correlated with carbon emission while being time and location organized. Elapsed real time. The total running time for generating an AI result is a natural measure for efficiency. As all other things being equal, a faster model is doing less computational work. Number of parameters. Another common measure of efficiency is the number of parameters used by the model. As with runtime, the measure is correlated with the amount of work. And the last one, FPO. FPO as a concrete measure. This article suggests reporting the total number of floating point operations required to generate a result. FPO provides an estimate of the amount of work performed by a computational process. To demonstrate the importance of reporting the amount of work, the article presented FPO costs for several existing models. Figure on the right showed the number of parameters and FPO of several leading object recognition models, as well as their performance on the ImageNet dataset. A few trends are observable. First, as discussed earlier, models get more expensive with time, but the increase in FPO does not lead to similar performance gains. For instance, an increase of almost 35% in FPO between ResNet and ResNext, the second and the third points in the graph, resulted in a 0.5% top 1 accuracy improvement. Similar patterns are observed when considering the effect of other increases in model work. However, FPO has some limitations. Most importantly, the energy consumption of a model is not only influenced by the amount of work, but also from other factors such as the communication between the different components, which is not captured by FPO. As a result, FPO doesn't always correlate with other measures such as runtime and energy consumption. Second, FPO targets the number of operations performed by a model, while ignoring other potential limiting factors for researchers such as the memory used by the model, which can often lead to additional energy and monetary costs. Finally, the amount of work done by a model largely depends on the model implementation, as two different implementations of the same model could result in a very different amounts of processing work. Due to the focus on the modeling contribution, the AI community has traditionally ignored the quality or efficiency of models implementation. The author argued that The time to reverse this norm has come, and that exceptionally good implementations that lead to efficient models should be created by the AI community. There are many ways to encourage research that is more green. In addition to reporting the FPL cost for each term in equation, the author encouraged researchers to report budget performance curves where possible. For example, training curves provide opportunities for future researchers to compare at a range of different budgets, and running experiments with different model size provides valuable insight into how model size impacts performance. This article further advocates for making efficiency an official contribution in major AI conferences by advising reviewers to recognize and value contributions that do not strictly improve state of the art but have other benefits such as efficiency. To conclude, this article states that it is important to see green AI as a valuable option, but not an exclusive mandate. The goals are to augment red AI with green ideas, like using more efficient training models and reporting training curves, and to increase the prevalence of green AI by highlighting its benefits, advocating a standard measure of efficiency. Well, thanks for listening.